Hello everyone, myself I am Divya from Department of Chemistry, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. In today's session, we are going to discuss a topic from the unit, that is water and its treatment, and the topic name is external treatment. And in the external treatment, we are going to study a process called as ion exchange process. What do you mean by external treatment? Before we send the water into the boiler trouble, the water should be in a pure form. So the treatment which we do to the water outside the boiler, we call it as an external treatment. So the treatment is given to water for the removal of hardness. The boiler trouble, boiler troubles are causing mainly because of the hardness present in the water. So if we remove the hardness before itself sending to the boiler, then we can prevent the troubles in the boiler. So in this case, we are going to do a treatment that is external treatment. That means we are going to treat the water outside the boiler for the case of removal of hardness. So the salts causing the hardness are removed and it is taken into the boiler, and this is called as the external treatment. And we also call this treatment as the softening of water. That means the water contains no ions in it. In industry, mainly external treatments we use is lime soda, zeolite and ion exchange process. So in our syllabus, we have the process that is ion exchange process. What do you mean by ion exchange process? From the word itself, we can say that the ions will be exchanged. And we also call this ion exchange process as deionization process or demineralization process. Why we call it as a deionization? Because the ions present in the water gets removed by this process. And demineralization process, and here why we call it by this name means minerals present in the water will be getting removed. So ion exchange process is also known as deionization or demineralization. So what this process? It includes the exchange of cations and anions of the dissolved salts by using of the H plus and OH minus respectively. So for these two types of ion exchanges, we are going to use to exchange the anions and cations. So to exchange the anions, we are going to use a anion exchanger, and to exchange the cations, we are going to use cation exchanger chambers. We are going to have two chambers. In one chamber, anions will be getting exchanged, and the another chamber, cations will be getting exchanged. So these are mostly of insoluble and cross-linked long-chain organic polymers with a microporous structure. So we are going to have a resins. So two types of resins we have. One is acidic and the other one is basic. The first resin is a acidic functional group. Resins with acidic functional groups which are capable of exchanging the H plus ions. So the resin with the acidic functional group will be capable of exchanging the which ions? H plus ions with the other cations. Now the resins with basic functional group, it will be capable of exchanging the OH minus ions. So the resin with the acidic group will exchange the H plus ions, and the resin with basic group will exchange the OH minus ions. And now these resins are classified as cation exchange resin, that is RH plus, and anion exchange resin, ROH minus. So we have two types of resins. One is cation exchange resin and the second one is anion exchange resin. What do you mean by cation exchange resin? As we have discussed in the previous slide, it is capable of exchanging the H plus ions. So these are mainly a styrene divinyl benzene copolymer which contains the sulfonic or carboxylic functional group. That means it is having H plus ions, and they are capable of exchanging their hydrogen ions with cations present in the water. So it is the structure of the cation exchange resin. One more we have is the anion exchange resin. So these resins are the styrene divinyl benzene or amine formaldehyde copolymers, and but this contains the amino or quaternary ammonium or quaternary phosphonium or the sulfonium groups as the internal parts of the resin matrix. So the ion exchange resins are made by like this, and this structure, and it is capable of exchanging the OH minus ions. So how the ion exchange process will take place? Coming to the process, first in the process, as you can see the diagram below, we are going to have one inlet. Okay, two chambers are present. One is the cation exchanger and the another one is anion exchanger. Okay, two chambers are present, and these two chambers are connected to one inlet, and through this inlet we are going to pass the hard water. The main aim of our process is hard water should be converted into soft water. The hardness or the hardness causing salts present in the water should be removed by the process, and the soft water which we get at the end of the process will be of pure. That means no ions or no minerals are present in the water. So coming to the process, first we pass the hard water through the inlet to the cation exchanger. So the first exchanger column is the cation and the second one is anion. So in the cation exchange column, it removes the all cations present in the water. So first we are sending the water into the cation exchange column. So the water may contain anions and cations. It is mixed, it is having both anions and cations. But what the cation exchanger bed will do, this cation exchanger will able to remove or capable of exchanging only the cations. So the water which is entered through the inlet to the cation exchanger, there it removes all the cations. That means whatever the water which we get the below is having water containing anions only. Now this water will enter through the anion exchanger. So as it removes all the cations from it, an equivalent amount of H plus ions are released from this column to water. After the cation exchanger, now the process, that means hard water which is present, is passed through the anion exchanger. The water which we get from the cation exchanger is next passed through the anion exchanger. In the anion exchanger, it is able or it is capable for removing all the anions from it, and the equivalent amount of OH minus ions are released from the column to water. Now through the two exchanger columns, through the cation exchanger and anion exchanger, we are able to remove the cations and anions. So the ions present in the water is getting removed. So the H plus ions and OH minus ions get combined to produce a water molecule. That is how here we get a soft water out. We are going to send a hard water in, but the product which we are getting is a soft water, which is demineralized, which is deionized water, which is very good for the purpose of industrial use. The water coming out from the exchanger is free from now cations and anions, because these cations and anions are already removed in the exchanger columns. Now, the cation exchanger or anion exchanger is having some resins, like these will be getting exhausted after some time or after the use. Now, these exchangers are again regenerated, as you can see here. To regenerate the cation exchanger, we are going to use the acid regenerator, and here to regenerate the basic, we are going to use alkaline regenerator. We'll see what is regeneration. So when cation exchanger loses its capacity of producing H plus ions, we need H plus ions and OH minus ions to be exchanged with the anions and cations that are present in water. So after the use of the process, after some time, the exchanger will lose its capacity. The capacity will be lost of producing the H plus ions and OH minus ions. In this case, we are going to follow the process that is regeneration. That means to the columns, we are going to connect regenerators. That means here, for the regeneration of H plus ions, we are using dilute sulfuric acid. To the regeneration of basic, we are going to use dilute sodium hydroxide. So by using of these two chemicals, we can able to regenerate the H plus ions and OH minus ions. The exhausted cation exchanger is regenerated by passing it through the dilute sulfuric acid, and the exhausted anion exchanger can be regenerated by passing through the dilute sodium hydroxide. So this is for the acid, this is for the basic. This is how we can regenerate the resins. Coming to the merits of ion exchange process, the main advantages of this process is, this process can be used to soften highly acidic or highly alkaline water. Whatever the hard water, if it is a highly acidic or if it is a highly alkaline, we can remove the acidity and basic or the ions present in the water by this process, and finally we can derive the soft water. It produces the water of very low hardness. The main theme of our process is to remove the hardness causing salt. So after the process, the water will have only a low hardness, that is 2 ppm only. So it is very good for treating the water used in high pressure boilers. We are performing this external treatment to the water before sending into the boiler, because when we are sending water with the hardness causing salts, we can see boiler troubles. So if we purify the hard water, like by converting into the soft water, you can see it is very good for treating the water for using high pressure boilers. These are the advantages of ion exchange process. Coming to the demerits of ion exchange process, the equipment is very costly. More expensive chemicals are needed for the processing of this ion exchange process. More expensive chemicals are needed. If water contains the turbidity, if water is having turbidity, then the output of the process will be reduced. So if we want the output of process the more good, then the turbidity should be very less. So the turbidity must be below 10 ppm. Below 10 ppm. Else it has to be removed by coagulation and filtration. We have seen or learned about these two steps in the potable water. So by the method of the coagulation or filtration, we can remove the turbidity. If turbidity is present in water, then the output process will be very low or reduced, and whenever we send a water to the ion exchange process, we must see that turbidity should be below 10 ppm. These are the references. Thank you.